Welcome to House of Past Paper Solutions. This is the 9709 Mechanics May June 2016 paper 4.3. So I'm going to be doing a thorough walkthrough solving each question in this paper. Also, if you need the papers 4.1 and 4.2, the links are in the description. So just go ahead and click on one of those papers and feel free to watch. Alright, let's get going. First question. A particle of mass 8 kg is pulled at a constant speed, a distance of 20 meters up a rough inclined plane at an angle of 30 degrees to the horizontal by a force acting along a line of greatest slope. Alright, so usually how I attempt these questions, this is the scenario that we have. First of all, it would be helpful to draw a diagram, especially if you're only starting to do these papers right now. So then just draw your diagram and draw your scenario. So we have the particle that is moving up the plane. This is the force acting downwards, and that's the force acting upwards on the particle, right? So it moves. We know that it moves a distance of 20 meters, right, up the plane. So this is gonna be 20 meters, distance of 20 meters up the plane. Okay. So it says here, part one says, find the change in gravitational potential energy of the particle. Right. So from physics, we know that GPE, change in GPE, right, is equal to mg delta h, right, in this case. We have the mass. We know what the value of g is. It's the constant of acceleration due to gravity, which is 10 meters per second squared, right? And then for the height, so we know that the question is saying that the particle moves a distance of 20 meters up the plane. So which means to get the height, we're gonna find the opposite side of the triangle, in this case of the inclined plane, which is just going to be delta h here is going to be equal to 20 sine 30, right? So to find GPE, now we just plug in the values that we have. The mass is 8 kgs, the value of g is 10 meters per second squared, delta h is 20 sine 30. Then when we plug that in the calculator, we get 800 joules, right? Since it's energy. Okay, so that's it for part one, question one, part one. And then part two, it says, the total work done against gravity and friction is 1146 joules, and find the frictional force acting on the particle, right? Remember, we have a frictional force. If we go back to the diagram here, we have our frictional force. This would be our frictional force acting downwards. Remember, friction always acts in a direction to oppose motion. Since our particle is moving up the inclined plane, right, as the question says here, and it says it's rough. So we know that there's friction here because it says it's rough, right? So we're gonna find the frictional force. So how are we going to do that? I'm gonna use an energy method for this particular question. That's the best way to approach it. So you simply say energy in. Since energy is conserved in this particular situation, it's going to be equal to energy out, right? So where's the supply of energy coming in? The supply of energy it's coming from the change in gravitational potential, right? Since it says here that the total work done against gravity and friction, right, is that we have it. So we know that GPE, right, and friction plus the work done against friction. I'm just gonna put the subscript F for friction is equal to 1146. That is the energy out, right? So we're getting, and we know what GPE is. So we just simply substitute and we work out what the value of F of WF is, work done against friction. So work done against friction in this case is going to be WF is going to be equal to 1146 joules minus delta GPE. And we found delta GPE as 800, remember here. So we substitute that, here we have WF equal to 1146 minus 800, right? So our WF is going to be equal to 346 joules, like that. Okay, but we haven't answered the question since it says find the frictional force, right? We know that The formula for finding the frictional force, or work done against friction, is equal to frictional force, F subscript F for friction, multiplied by the distance it travels. We know that the particle travels a distance of 20 meters up the inclined plane from the question here, right? So I'm gonna write here if friction is going to be Fw F over D. Substitute those values, which is 346 over the value for D, which is 20 meters. And then I'm gonna get 17.3 newtons for 3SF. Three significant figures, right? And then that's it for number one. Okay. If you want to take a screenshot, you can take a screenshot right here. Just going to clear up everything. Okay. Make space for question 2. Question 2 reads, Alan starts walking from a point O, right? At a constant speed of 4 meters per second along his horizontal path. Ben starts walking along the same path, also starting from O. Ben starts from rest 5 seconds after Alan and accelerates at 1.2 meters per second squared, 5 seconds. Ben then continues to walk at a constant speed until he is at the same point P as Alan. Okay, so this is the situations that we have. Part 1 reads, find how far Ben is traveled when he has been walking for 5 seconds and find his speed at this instant. Okay, so I'm going to draw a graph to show you the scenario that we have here. I'm going to draw a VT graph, a velocity time graph. Velocity time graph. Right, okay. Right, so this is the scenario that we have. So this is V meters per second, and this is T in seconds. Right. The question is saying that Alan starts from point O. So I'm just gonna label this point O when it starts. Yeah, point O, something like that. When Alan starts walking. So it says that he starts walking at a constant speed of 4 meters. Right? So which means we go to our graph and we mark 4 meters. 4 meters per second. Right there. That's gonna be our 4 meters per second square, right? And then it says that he walks at a constant speed. So it's gonna be a straight line. Right? It's gonna be a straight line on the graph. Then it also tells us about Ben. So it says that Ben also starts from the same point O, but then Ben starts 5 seconds after Alan has already left, right? Starts from rest 5 seconds after Alan, right? And accelerates at 1.2 meters per second square for 5 seconds. So we know that Ben is increasing his speed for 5 seconds. Right. So I'm gonna mark here for 5 seconds. For when t is 5 seconds, Ben is increasing his speed. We want to calculate the velocity the final velocity that Ben has after those 5 seconds, right? Since Ben starts at rest, we're going to use a Sauvage equation. And since the acceleration that Ben has is constant, we're going to use a Sauvage equation to find the final speed that Ben has. Okay, so I'll use the equation V is equal to U plus AT, right? And I know that Ben starts from rest, so that is 0. So the final velocity is going to be equal to the acceleration, which is given here, is 1.2, multiplied by the time Ben walks. He walks for 5 seconds, right? That's going to give me 6 meters per second. So I'm going to go back on my graph and mark the 6. 6 meters, yeah. So I know that from 0 all the way up to 5, okay, Ben has a constant acceleration of 1.2 meters per second squared, right? Then it also says that Ben then continues to walk at a constant speed until he's at the same point P as Alan. So from then, after the 5 seconds, he starts walking at 6 meters per second squared, right? Which is a constant. This should be a straight line. Okay, like that. Until it reaches some certain point P. Right. So now it says, question 1 says, find how far Ben has traveled when he's been walking for 5 seconds. So I'm going to use we know that to find the distance for part 1, then we know that distance is equal to the area of a VT graph, right? Of a velocity time graph. In this case, this is what we need. So it says for 5 seconds, find the distance he has traveled for 5 seconds. So this is what we need. We just need this portion here, which is a triangle. We know what the area of a triangle is. Area, in this case, is going to have base times height, right? You can just plug in half. I'm gonna take my base as 5 seconds, and my height is the 6. When I plug that in the calculator, I get 15 meters, right? So that's it for the first part. I've already calculated the first part here. So the first part, what you just needed was the height, which is the 6 meters, and we got that using the Suvart equation, since acceleration was constant. Okay. Second part says, find the distance OP. So I'm gonna show you the easiest method to approach this second part. What you do is, you think of the scenario, use intuition. So we know that since Alan starts walking at a constant speed of 4 meters per second, right? And then 5 seconds, and then Ben follows. He walks with at an acceleration of 1.2 meters per second, 5 seconds, right? But then we know that at some point, right? At some point, when the time is equal, at some point on their journey, they're gonna be at the same point, at the exact same point. So that is the what we're going to use to find the distance OP. We're going to use the fact that at some point they have at some point on their journey, which means when their time is going to be the same. When that time is going to be the same, they would have traveled the same distance. I don't know if that makes sense. Since Ben is walking faster than Alan, at some point he's going to catch up, right? So we want to find what that point is so that we can find the distance. Okay, so I'm gonna put the T here. So at some point, right? At some point, they're gonna be sharing the same time. They're gonna be at the exactly same. They're gonna have the same time, and they're gonna have traveled. They would have traveled the same distance, right? So I'm gonna make two equations, two distance equations, and then I'll find what the time would be for those distances to be equal, right? So let's do it. I'm just going to clear space here. Okay. So part 2. So I'll do part 2. Okay. So we're saying SA and SB and SB. At that point in time, when they have the same distance, that also means their areas is going to be the same, right? They'll be equal. They're going to be equal. Therefore, area for SB, for SA, is going to be equal to area for SB. Okay. So I'm going to use the area for SA SA, right? Which is the displacement or the distance that Alan is moved, is going to be equal to, using the Stewart equation, in this case I'm going to use just the area, right? Which is the area of Alan, right? It's going to be a triangle. If you look at this, it's going to be a triangle like that. Okay, so I'm going to use that area, which is going to be the length times the width. The length is going to be t from 0 to t, and the width is going to be 4. Okay, so I'm going to put that there. Length times width. Length is t, and so it's going to be 4 divided by t. So it's just going to be 4t. And then same thing for SB. The distance traveled by Alan. I'm going to use the area as well. SB is equal to, in this case, it's going to be equal to the area of a trapezium, right? Look at it, because it's gonna take this shape for AB. It's gonna take this shape, so it's gonna be the area of a trapezium, right? Okay. So the area of a trapezium, it's half A plus B H. And I'm gonna say half the A. I'm gonna take it as this part. So that is just T, right? And then plus the H. I mean the B. This is B. The B is going to be this part, which is just T minus 5, right? So I'm gonna write the T minus 5, and then bracket multiplied by the height, which is just going to be 6 meters. This is going to be the height, which is 6. Okay. Then I plug that in, simplify that. That's going to be 2t minus 5 multiplied by 6. So I want to equate this so that I can solve for t. So I'm going to equate SA and SB. SA is equals to SB. Remember we said at point P, the distance that Alan is traveled is going to be the same distance as Ben travels, right? Okay, so I'm gonna equate those two. It's gonna be 14 is equal to half 2t minus 5 multiplied by 6, and then I'll solve for t. Multiply that after the side, multiply that 3. I'm gonna multiply 3 in, and 4t is equal to 6t minus 15. Take that to the other side, get negative 2t is equal to negative 15 divided by negative 2 time is going to be equal to 15 over 2, which is also the same as 7.5 seconds. So what does this time show us? This time is saying that after 7.5 seconds, both Alan and Ben be at the same point. So now we just find what that point is using any of the equations that we had, because this was equation 1 and this was equation 2, and we solved them simultaneously. So we can just plug in the 7.5 in any. So this is the easiest thing. It's 40, and we know that t is 7.5 now. So you can just multiply 4 multiplied by 7.5. When you plug that in your calculator, you're gonna get 30 meters. Right, and that's your answer. So the distance OP, right, where they meet, where both Alan and Ben will be, is going to be equal to 30 meters. And that's it. Right. It's going to clear this up. Okay. Question 3. Question 3 reads, the coplanar forces shown in the diagram are in equilibrium. Find the values of P and theta. Right. Since it's saying that the forces are in equilibrium, we know that the total summation, considering the directions in the x, so this is the positive x, this is the negative x direction. Since remember force is a vector, it is magnitude and direction. So we have to select which one is going to be our positive direction, which one is going to be a negative. So I'm just going to take the left as the negative and the right as the positive. Same with the upwards and downward direction. Upwards is positive and downwards is negative. So you're saying both of these forces are cancelling out. Right? They're all cancelling out to give us zero, an overall force of zero, resultant force of zero. That's why it's in equilibrium. That's what it means. So we know that the resultant force in the x direction, the pluses and the minuses, it will be equal to zero. And we also know that the summation of the forces in the y direction, they're also going to give us zero. So I'm going to use this fact to calculate the values for p and theta. Right? I'm going to make two equations and then solve them simultaneously. Okay. So I'm going to first resolve. First, I'll solve for the summation in the x direction. Okay. So I'm going to resolve the 12 Newton force in the x direction. When I resolve that, I'm going to get 12 cos 75 12 cos 75, and then I'll also resolve the p Newton force. When I do that, it's going to be p cos theta, right? Minus, I'll resolve the 18 Newton force. It's now I'm going to say minus now because it's in the opposite direction. It's acting in the opposite direction. 18, if I resolve the 18 Newton force, this is the force that I want, right? It's in the opposite direction. 18 cos 65, and if I resolve the 15 Newton force, it has no component. It's going to be 15 cos 90, and cos 90 is just zero, right? So I won't be including the 15 Newton force because it doesn't have a horizontal component. And then that is going to be equal to zero. Then I'm going to simplify, take these two to the other side. I'll take them to the other side. Then I have p cos theta is equal to 18 cos 65 minus 12 cos 75. And that will be equation 1. Okay, then I'll do the same, resolve in the y direction too. Okay, when I do so, I'm gonna have the 18 Newton and the 12 Newton force are acting in the horizontal upward direction, right? So when I resolve those two, I'm gonna get 18 sine 65 plus 12 sine 75, and then I'm gonna subtract the forces acting downwards. In this case, 15 is acting downwards, right? Since it has a 90-degree angle here, you can say 15 sine 90. Sine 90 is just 1, so it's just gonna be 15 anyways. It doesn't have, it's a full vertical component force. Full vertical force, right? And then I'm gonna subtract the resolution of p, the vertical direction, which is p sine theta. Right? If I resolve p like that, if I draw a triangle here, so you can see this is theta, this will be p sine theta, and this will be p cos theta. Okay. This diagram is now a bit messy. I'm just gonna rub these out now. Okay. P cos theta is equal to 0. Then I'm just gonna take p cos theta to the other side so that it's a positive. Okay. So I'm gonna have p sine theta is equal to that. There we go. Then that's going to be equation 2, like that. Okay. Then I'll solve equation 1 and equation 2 simultaneously. Right. If I divide equation 2 over equation 1 to get tan theta. It would look something like that. P, it will be P sine theta, right, over P cos theta. Then it's going to be equal to 18 sine 65 plus 12 sine 75, and all of that going to equal to over 18 cos 65 minus 12 cos 75. Like that. Okay. And then the p's will cancel out. This will just give me 10 theta. Right. So I'm gonna have 10 theta. 10 theta is equal to all of that. When I put that in the calculator, I'm gonna 10 theta is going to be equal to all of this. And theta is going to be equal to all of that. And then theta is going to be the tan inverse of all of that in the calculator. Plug that in the calculator. And then you're gonna get theta is 70.8 degrees. That. Okay. To 3SF. I mean to one decimal place. Remember, for degrees, for angles, it has to be to 1 dp. 1 dp for angles. It's 1 dp. Then for other values, it's 3 significant figures. All right. And then to get p now, I can use equation 1 and 2 again. Remember the trig identity, sine squared theta plus cos squared theta is equal to 1, is identical to 1, right? So I can square those, and then, so it will look something like this. P squared sine squared plus, I can square those equation 1 and equation 2, then add them together. Okay, so it's like this. I'll say equation 1 squared plus equation 2 squared, right? It's going to look something, then it's going to be P squared sine squared theta plus cos squared theta, right? And this is the P squared right here. Is all equal to these here. I'm not going to rewrite them again, but you can just plug them in the calculator. These two, right? Which is 1 squared plus 2 squared. And then you can factor out the P squared thing. P squared. Then you're gonna have your sine squared theta plus cos squared theta, which is equal to that, right? And this, using this trig identity, is just going to be 1. Therefore, P squared is going to be equal to 1 squared plus u squared, right? Then you can square root both sides. You can root both sides to get your value for P. P is equal to square root of that. When you plug those in the calculator, if you plug 1, this is 1 squared, right? And then you also plug 2 squared, right? That's what I'm representing with the 1s and the 2s. 2 here squared. You're gonna get your value of P as 13.7 newtons. And that's it. Those are your 2 answers, right? There you go. Okay. Question 4. reads the right there. The particle of mass 15 kgs is stationary on a rough inclined plane at an angle of 20 degrees to the horizontal. Right. The coefficient of friction between the particle and the plane is 0.2. The force of magnitude x acting parallel to the line of greater slope of the plane is used to keep the particle in equilibrium. Show that the least possible value of x is 23.1, correct to 3 significant figures. Find the greatest possible value of x. Okay, so the first thing that I'll do to approach this question is draw a diagram, sketch a diagram to the side, and then that way you won't make silly mistakes. Okay, so we have an inclined plane, okay, like that. Okay, then we have our mass. It is a force acting up the plane. Then it is a force is acting down the plane. Okay, like that. All right. Since the question says that the particle is in equilibrium, that means that the forces acting up the plane, down the plane, perpendicular to the plane, all of them, when we get the resultant force of them, is going to be equal to 0 since it's in equilibrium. The same thing that we did for question 3, right? Whenever it says equilibrium, that means that something is not moving, right? But in this case, since it's saying it, show that the least value of x is 23.1. Remember, we have the x is acting parallel to the plane, so this is the force x. We're going to show force x. What's acting down the plane parallel to the plane is the downward component of the weight, right? Remember, we know that weight acts down. It always acts down the plane from the particle, right? We know that the weight always acts vertically down, right? Excuse me today. I don't know what's going on. Right. So this is the weight which is mg, right? And then we know that this angle here, we've been told this angle is 20 degrees. If we do the geometry, this is the particle that we have. Then we have that component. We have that is the weight, right? So mg, like that. I've just taken this particle here and drawn it here. This is the particle. This is the mg weight. And then we have the component that is perpendicular to the direction of the plane, right? This here will be 20 degrees. If you do the geometry, that'll be 20 degrees. Okay, if I show it, that component right there, looks like that. We remember we have reaction acting up, then with the component of weight that is perpendicular to the direction of the plane, right? And then we have the component of weight that is parallel to the plane. This here, I'm trying to say this part would also be equal to 20 degrees. If you do the geometry, you see that this part is also equal to 20 degrees. That's what I'm trying to show here. So you have the reaction in that direction. Then you have the component of weight acting perpendicular to the plane. Is mg cos. See, this is now a triangle. This is a triangle, a right angle triangle right there. Mg cos 20. So what I'm simply doing is just resolving the weights. Okay. And then the component that is acting parallel to the plane is this one, which is also the same as this. This is the same. That would be mg sine 20. So this is mg sine 20. Right. So I'm gonna write that here. is mg sine 20, then acting up with x, okay, and then this is going to be equal to mg cos 20, like that. Mg cos 20, and this is just going to be equal to mg, like that. Okay, so the question tells us to show that the least value of x is 23.1. How do we determine the direction in which the friction is acting? Remember, friction acts in the direction that opposes motion. So in this case, to get, what do you think? For x to be the least, right, the friction has to act up the plane. All right. So that means x plus the friction have to be supporting the particle, not roll down, right? So I'll put the friction here going up the plane like that. That'll be the friction force, right? We're going to use Newton's second law of motion. That is why I'm putting the friction up. I'm going to use Newton's second law of motion. Okay. Newton's second law of motion, which is that this total summation F, right, is equal to ma, right? The resultant force will give us an acceleration, but in this case, since there's no movement, the acceleration, we know that it's equal to 0. It's in equilibrium, so therefore resultant force is going to be equal to 0, right? So for least value of x, this question, least x, friction x up the plane, like that. Okay, so I'm gonna use that factor using the formula, the Newton's second law of motion. So the force is acting up the plane, it's x plus the friction force, just like I showed here on this diagram. X and the friction and the frictional force, right, is equal to the force acting down the plane, which is this one, which is the horizontal component, or the component of the weight parallel to the direction of the plane, right? Of the inclination of the plane, right? It's mg sine 20. You might wonder why I also resolved the reaction. And mg cos 20 is because it's going to help us to find the frictional force. Recall that frictional force is equal to mu r, right? And we know what mu is, the coefficient of friction. The question told us that it was 0.2 multiplied by the reaction. We also use Newton's second law in this case to find the balancing forces, right, for the reaction, to find what the reaction is. We know that the particle is not moving up or down, therefore its acceleration up or down is also equal to 0. So we equate these two. So it'll be something like this. It'll be something like r, right, minus mg cos 20 is equal to 0. Therefore, I can take that to the other side. Therefore, r will be equal to mg cos 20, like that. Okay. All right. So I'm gonna plug in this equation. This would be times the reaction. We know the reaction now is mg cos 20, right? Therefore, x now is just going to be simply equal to mg sine 20 minus ff, frictional force, which is this. Just gonna plug that in, 0.2 multiplied by mg cos 20, right? So that's our list X. So when I plug in those values, the values for mg, it's gonna get X is equal to 15 multiplied by 10 sine 20 minus 0.2 multiplied by 15 multiplied by 10 multiplied by cos 20. Plug that in the calculator, you get 23.1 newtons exact, and you would have shown like that. Okay. Now it says find the greatest value of x. So the greatest value of x is when greatest x friction is down plane. Friction x down the plane. Okay. Therefore, using Newton's second law, now this friction here is moving. It's no longer, this friction is no longer acting up plane for the second scenario. It's now acting down plane. That means that x is to support the weight of the component acting parallel to the plane and the frictional force, which means it will have to be greater than 23.1. Okay, so using the same formula, Newton 2 Fm is equal to ma, which is equal to 0 in this case. So there's no acceleration, there's absolutely no movement. Therefore, the forces are balanced. So the x that is acting up, right, is simply going to be equal to minus ff minus mg sine 20 is equal to 0, right? Then I take this to the other side like that. Then I get x is equal to ff plus mg sine 20 is equal to that. We know what the frictional force is. We already calculated it. It was 0.2 multiplied by mg. I'm just going to substitute in for the mg. Multiplied by 10 multiplied by 15 for the mass, 10 for the g, cos 20. Then I'm going to add that to the mg sine 20, which is 15 multiplied by 10 multiplied by sine 20. When I do plug that in the calculator, I'm gonna get an answer of 79.5 newtons. And that's how you calculate. That's how you work out question 4. Okay, here's the full scope of question 4. Okay, question 5. Okay, question 5. Question 5 reads, the motion of a car of mass 1400 kgs is resisted by a constant force of magnitude 650 newtons. Find the constant speed of the car on a horizontal road, assuming that the engine works at a rate of 20 kilonewtons. Okay, I'm gonna draw the the scenario that we have. We have the car, which is a driving force. I'm just gonna call it D, and then there's a constant resistive force of magnitude 650 newtons, right? Okay, so it's saying that the engine works at the rate of 20 kilowatts, and then it says find the speed, right? We're going to use the power equation. We know that power is equal to driving force multiplied by v, the speed, right? In this case, we have it as 22 kilowatts, which is the same as 22 by 10 to the 3, right? And then using Newton's second law, we know that resultant force is equal to ma. But since it says that we're traveling at a constant speed, we know that the acceleration is equal to 0. Therefore, d minus 650 is equal to 0. D is equal to 650. If you want to understand these concepts, just head over in the description. There are links to the videos where you can which you can watch in order to get a better understanding of this Newton's second law concept. Otherwise, you're going to be confused most of the time. I mentioned this formula here, right? So d is equal to 650, right? Now I can substitute that d in the power equation to get v. So v is going to be equal to power divided by d, and power is 22 by 10 to the 3 over the d, which we just calculated, 650. V is equal to, is the fraction 400 over 13, which is equal to the three significant figures, 3.8 meters per second, right? And that's our answer. That's it, like that. And then part 2 says, the car is traveling at a constant speed of 10 meters per second up a hill, inclined. Now the hill is inclined now, at an angle theta to the horizontal, where sine theta is equal to 1/7. Whenever we get one trig ratio, that means we will have all the other trig ratios, because we just use a triangle and then use the Pythagoras theorem to find the other value that we don't have, the other vertices of the triangle that we have. And then once we have that, we now have cos, tan, and sine, right? Okay. So it says find the power of the car's engine. Okay. Okay, I'll clear that up for the second part. Part 2, right? It says that, so this is a scenario that we now have. Okay, so the triangle would look something like that. But really in the exam, I wouldn't draw the triangle. And then we have a particle moving like that. And then the force is acting on the particle. If you really want a detailed video on how I resolve the weight component, as I did in the previous question, the weight component, which is mg, I resolve it to mg sine theta, and I resolve it again to mg cos theta. If you want to know how this works, there's a link in the description. You can find a video where I thoroughly explain how this works. I'm just going to wrap this out. In the exam, I'll just show this. I'll just show the particle like this if I was doing it myself, and then I'll draw arrows. That's all. What do you use? So in this case, now we have the car moving moving up an inclined hill at an angle theta, right? So we have the forces acting down the plane. In this case, it's going to be the 650. Remember, the question here tells us that it is a constant force of resistive force of magnitude 650. This could include the friction, the air resistance, and all those other frictional forces. All right, and then we're also going to have mg sine theta, which is the component of the weight acting parallel to the incline. And then we're also going to have d now. We're also going to have d. This is now a new d. I'm just going to call it d naught. Okay. The question says that find the power of the engine. So the power, we know that power is equal to the driving force, right? D naught multiplied by v. We have the velocity. It tells us that it's 10 meters per second. So we need to find d. To find d, I'm going to again use Newton 2. If you also don't understand the use of the Newton's second law throughout this entire paper, check out the link in the description, where I thoroughly explain how the Newton's second law works. So it's the summation of the forces equal to ma, right? Acceleration is 0. It says that it has a constant speed, 10 meters per second, right there. Right? That's the question. 10 meters per second is 0, right? Then I'm gonna use that vector and apply it to our scenario here. Okay. So I have d acting up minus the opposing forces, and 650 is all of it is equal to 0, since the acceleration is 0. Thus, d naught is equal to mg sine theta plus 650, right? Sine theta, I have it as 1 over 7, is given in the question. Mg, the mass, I have the mass is 1001. Thus, d naught is equal to 1400 multiplied by 10 multiplied by 1 over 7 plus, right, plus 650, like that. Okay, that's the d naught. Then remember the power formula. Okay. I want to calculate the power. Power is going to be equal to d naught multiplied by v, which is going to be equal to 1400 multiplied by 10 multiplied by 1 over 7 plus 650, right? I'll bracket that. Then we'll multiply that by 10. When I plug that into the equation, I'm going to get 26,500 watts. And the question says, find the power of the car's engine, right? And that's it. And you can just write it as 26.5 kilowatts if you want. It's fine. That's it. That's it for part 2. If you want to take a screenshot, you may take a screenshot. Okay. And then part 3. The car descends the same hill with the engine working at 80% of the power found in part 2. So the power that I found in part 2, that power was 26.5 kilonewtons from part 2. Right? That's the power that I found. So it says it descends with working at 80% of the power. So the power new now, P naught, is going to be equal to 80% of 26.5 by 10 to the 3, right? When I do that, I get 21.2 kilonewtons, or 21.2. When I plug that in a calculator, 21.2 by 10 to the 3 watts. Okay, that's the new power. Then the question proceeds, find the acceleration of the car at an instant when the speed is 20 meters per second. Okay, see, now we need to find the acceleration. You see, now we go back again to Newton's second law. If you really do not understand where Newton's second law comes in, please watch the video in the description where I thoroughly explain how it works. Okay, Newton 2 again. The resultant force is equal to mass times acceleration. Now we need to find this acceleration, because the question is told us that there's now an acceleration. And you see that there'll be an acceleration when I find the resultant force. It won't give you 0 this time. So this is the scenario that we now have. I'm going to draw the scenario now. We have the particle, the car, right? The force is acting up the plane. Remember, it's now descending. That's mu, right? Then acting down the plane. In this case, we have the mass, the weight component acting down the plane, plus, and then we have the d, right? I'm just gonna call it d2 now. Okay, d2, the driving force, the new driving force, right? So I want to find this force. And then the force is opposing again, it's our 650. It remains constant throughout the question. If they mentioned the result, the resistive force in these parts, that means it only works for the parts. But if they mention it as an information, as information of the part of the whole question, like at the start, right, at the outset of the question, right here, that means that you have to use that force, that resistive force throughout the entire three parts, the entire parts of the question. But if they mentions if they mention here, let's say they say the resistive force is equal to 650 just on this part, that means you only use it for that part. But if they mention it right as part of the information of the question, that means you use that resistive force of magnitude 650 throughout the question. I know this was a common error that some of my students were making. Okay, so I'll use the power equation to find this d2. Okay, so we know that power P naught is equals to driving force 2 multiplied by the velocity, right? The velocity is given, it's 20 meters per second. And the power, we also have it, it's 80% of 26.5 kilowatts, right? Which was 21.2 kilowatts. So D2 will be equal to 21.2 by 10 to the 3 divided by V, which is 20. Therefore, D2 will be equal to 1060. Plug that in the calculator. You get 1060. Right. Now, let's use Newton's second law. Right. How where does it come into place? We know that D2 this is equal to 1060. So the resultant of the forces acting on the car will give us, is now giving us an acceleration. Right. Since the question tells us there's an acceleration. Right. Okay. So we say 1060 plus mg sine theta, right, minus 650 is giving us an acceleration now, which we need to find. So that acceleration is going to be equal to 1060. Then I'm going to substitute in the values for mg sine theta, which is 1400 multiplied by 10 multiplied by the 1 over 7 for sine, right? Then I'm going to subtract 650 like that. Then all of that is divided by the mass, which is 1400 kgs to get the acceleration. And that will give us, as a fraction, 241 over 40. The three significant figures give us 1.72 meters per second squared. Like that. And that's our acceleration. That's it for our part. That's it for question 5. Okay. Let me take a screenshot if you want. Okay, question 6. Question 6 reads, two particles of masses 1.3 kg and 0.7 kg are connected by a light inextensible string that passes over a fixed smooth pulley. That means it's frictionless. The particles are held at the same vertical height with the spring taut. The distance of each particle above a horizontal plane is 2 meters, and the distance of each particle below the pulley is 4 meters. Okay, the particles are released at rest. Find A, tension in the spring before the particle of mass 1.5 reaches the plane. Okay, the first thing, I'm gonna draw the scenario again. It looks something like this. We have a pulley, right? Then, okay, we have a pulley. Okay, yeah, something like that. Then goes down. Right, so it says we have 4 meters from the pulley. Maybe right about that distance. Right about that distance is 4 meters. Then we have our particles, right? Then the distance to the ground, distance to the floor, just to the horizontal plane, the distance to the horizontal plane, the distance thing is 2 meters. The distance is 2 meters. Okay. Right. That's a scenario that I have. Like that. So the first particle is 1.3 kgs. kg. The second particle is 0.7 0.7 kgs, right? Since this one is a bigger particle, okay, this is the bigger particle. Since the 1.3 is the bigger particle, when the particles are released, the 1.3 kg mass is going to pull. So the pulley will move in this direction. Like that. It's going to pull the 0.7 kg mass. Okay, like that. Then it says, find the tension in the string before the particle of mass 1.3 kg reaches the plane. So what I'll do, I'll resolve the forces. So from the diagram, I'm gonna draw a side diagram to show you the forces acting on each particle, right? This is the 1.3 kg mass particle, 0.7 kg particle. So we're gonna have the weight, which is mg, acting down. In this case, it's gonna be 1.3 g. And then the weight for the 0.7 newtons, 0.7 g. Then we're gonna have the tension, in this case, acting up, right? Which is gonna be the same tension acting up again, this particle. But since we know that the pulley moves in that direction, it's shown on the diagram in purple. I'm going to use Newton's second law again. See, for mechanics, if you don't understand Newton's second law, I don't know what you do, honestly. So from Newton to, again, that's what I'm going to use, which says that the resultant force, in this case, we're going to have an acceleration when the particles are released. 0.1 kg down is going to move down. As this moves down, right, 0.7 kg mass will be moving up when the particles are released. So the summation of the forces acting on the particle is going to be equal to ma, mass times acceleration. We're going to have an acceleration. So I'm going to form two equations using these two, the 0.1 kg is 1.3 kg and the 0.7 kg. Right. I'm going to form two equations using the forces that are acting on them from the Newton's second law. So for the 1.3 kg mass, it's going to be equal to 1.3 g minus the t, right? Since the 1.3 kg, 1.3 kg mass is going to be moving down. That means it's going to outweigh the force that is opposing that motion, which is t, and that's going to result in an acceleration. Therefore, is equal to the mass, which is 1.3, multiplied by the acceleration that we don't know. Right, that's our equation 1. Then also do the same thing for 0.7 kg mass. It's moving up in this case on the pulley. Therefore, the tension is greater than the 0.7. kg mass, which is 0.7 g in this case, right? The force that is opposing the tension. And then that is equal to ma, which is 0.7. The acceleration we don't know, but it is the same. It's the acceleration for the 1.3 kg particle, 2, right? Then I solve those two simultaneously. In this case, it's very easy. I'll just add that goes away. Then I'm gonna have 2g is equal to 2a. I'm gonna have 2g is going to be equal to 2a, right? Like that. But it's actually 0.6 because I'm subtracting 1.3 minus 0.7. So it's going to be equal to 0.6 g is equal to 2a. Therefore, the acceleration is going to be equal to the g value for g is 10, 0.6 multiplied by 10 over 2, right? Over 2. That is just 6 over 2, which is 3 meters per second. Sweet. Right, but we haven't answered the question. We're going to calculate the value for t. You can just substitute the 3 meters per second in one of these equations, and you'll find t. I'm going to use equation 2. From 2, t is equal to 0.7 a plus 0.7 g. Therefore, 0.7 multiplied by 3 plus 0.7 multiplied by 10. If you add those two, you're going to get your value of t as, you're going to get the value of t as 9.1 newtons. Like that. And we've answered that part. Okay. Then part 2. Find the time taken for the particle of mass 1.3 kg to reach the plane. All right. Since we have the acceleration from our scenario, this is the 1.3 kg mass, right? So this is the 1.3 kg mass. It's going to be, we know the distance that it has to travel to reach the plane. We're told by the equation that is 2 meters to reach the horizontal plane. And we know that it is an acceleration of 3 meters per second squared, right? Like that. So I'm going to use the Stewart equation. The acceleration is constant. So I'm going to use the Stewart equation to find the t. The Stewart equation is s is equal to ut plus half at squared. Remember, you can use Stewart equations as long as the acceleration is constant. Once the acceleration varies, that means you're probably going to use calculus, right? And then we know that it starts off at rest, so u is 0. That s, we have it as t. So we're going to rearrange to find t. T is going to be t, when we rearrange, t is going to be 2 multiplied by s. That's 2s. Then we divide by the acceleration. Then we root that. Of course, it's plus or minus, but we know that t is an element of the positive reals only, right? T can never be less than 0, right? T can never be less than 0, right? So t is going to be equal to positive root multiplied by 2 over the acceleration, which is root 4 over 3. Then when I put it in the calculator to 3 significant figures, we get 1.15 seconds. Therefore, my second answer is 1.15 seconds, like that, to 3SF. And that's it for the first part. There you go. Now I want to go to the part 2, right, which says find the greatest height of the particle of the 0.7 kg above the plane. All right. So what they're asking is, remember, is this remember, as the 1.3 kg mass goes down, the 0.7 kg mass goes up. So it's saying find the maximum height from here. So we need to find some height that it reaches. That's the max height that we need to find. Okay. Right. So I'm gonna use an intuition again. Let me make space here. Flip. So I'll play out the scenario that we have for you here. That we have for question 6 part 2. It says that so this is what happens. So I'm gonna draw the scenario. What happens? Okay. So when okay, let me draw. You have the horizontal plane, right? And then you have your pulley B. When the 1.3 kg mass reaches the floor, right? When it gets to the floor at that point, remember it started off here and it would have moved a distance 2 meters, a height of 2 meters, right? And then we know that the 0.7 kg mass will be about somewhere. Okay, this is the 0.7 kg mass, and this is the 1.3 kg mass. Okay, it would have also moved 2 meters up the plane, up the 2 meters up relative to its initial position. Remember, both of them started here at this point. Both of them started at this point, and then the 1.3 kg moved down. Simultaneously, the 0.7 kg mass moved up, right? So remember that they had an acceleration also of 3 meters, both of them. 0. This one, I'm just gonna call it mass A, and this one mass B. When mass A reached the plane, or moved down the plane, it had an acceleration of 3 meters per second down, 3 meters per second squared downwards, right? At the same time, mass b, right? It needs the same acceleration of 3 meters per second speed, but in the opposite direction, right? So when as soon as the 1.3 kg mass, which I'm calling mass A, reaches the plane, that means that there's no longer any tension pulling up the 0.7 kg mass, or mass B in this case. We're calling it mass B. So that means the tension acting up becomes zero. The moment, the exact moment that the mass A reaches the plane, this tension here becomes zero. This tension here becomes zero, right? And at that very instant, um, the mass B, it is still moving up, right? But then in this case, now it's decelerating. Remember, it just things just don't abruptly stop. They first lose that energy. So it will lose that energy. It will still move up a certain distance. So let me rub this out to show you. So from this point here, it will move up a certain distance as it decelerates. Remember, now it's in free fall. It enters free fall. In the acceleration, it moves up, right? But with a new acceleration of -10 meters per second squared. Remember, acceleration due to gravity acts downwards. It always acts vertically downwards. So it moves up as it decelerates. So the moment A reaches the plane, right, B here has a velocity, right? And it loses that velocity, that kinetic energy, right, as it moves up to a certain maximum height, which we don't know, right? To a certain maximum height, which we don't know. But here we know that it had moved 2 meters up, right? And it will move a certain distance up. We know that we're told that this distance here is 4 meters, but in this question it doesn't matter. We're told that it's 4 meters. From the starting point of the masses to the pulley, it's 4 meters, but it won't matter. So this is the intuition that you should have. So we need to calculate this S max. So to calculate that X max, the first thing that you do is you'd find the velocity of B, or of the 0.7 kg mass, at the moment that the particle A reaches the plane. That's the velocity that we need. And we can use the Suvat equation. Since we know that the acceleration is constant, we can use the Suvat equations, right? Okay. I'm going to minimize that. Okay. Since we know that the acceleration is constant, we can use the Suvat equations. And that is what I'm going to do. So first I'm going to find the velocity of B, right? Of B, the velocity of B, one. The velocity of B, which is the 0.7 kg mass, right? After the 1.3 kg reaches the plane. At that instant, so we know that the the particle A reaches the plane after the time that we already calculated, which was 1.15 kgs. So after the 1.3 kg reaches the plane, so I'm gonna calculate that velocity, and then so I'm gonna calculate that velocity of the 0.7 kg mass. I'm gonna use the Suvat equation. V is equals to U plus 80, right? We know that it starts off here at this point with the U of 0. We need to calculate that V here, right? We have the time and the acceleration. So V is equals to, the acceleration is 3 meters per second. The time is the same time that just the particle A, or the 1.3 kg, takes to reach the plane. We calculated it was 1.15, and more accurately, as I said, it was root 4/3. Okay, like that. That's the v that we're gonna have. Okay, then again, we're going to come back to Newton's second law. Now we need to find, I want to use that Newton's second law to find the distance, the S max, that the point B travels after the 1.3 kg or the particle A has reached the plane. Right. So the scenario that we have now is this. This is the 0.7 kg mass. When particle B, 1.3 kg, reaches the plane, tension here becomes 0. So we no longer have that force acting. We only now have the weight, the 0.7 kg mass acting down, which is 0.7 g, right? Acting down. Okay. So I'm gonna calculate S max using a Sauvé equation again. Because remember the acceleration, it's now in free fall, but the acceleration is gonna be -10, right? Moving up. So I'm gonna use this equation. V squared, in this case I'm gonna say V2. V2 squared is equals to U2 squared plus 2A, right? A2, then A2 or max, in this case S max, which what I need, right? So this is going to be the new velocity after it has traveled the distance S max, right? The velocity that we have, the V that we calculated, this one here, which becomes 2 root 3, will now be the U, right? Once the particle, the 0.7 particle has reached the maximum height. So it moves up, right? It moves up, then it reaches the max height from the point where it was. It reaches the max height, S max in this case, or X or S2. It reaches the max height, right? So I'm gonna use that fact to calculate. And then we know that when it reaches the max height, its velocity now, which is v2, should be equal to 0, right? The initial velocity that it had, which was v, which is now v, this v here, which is now equal to u2, is equal to 2 root 3, right? And the acceleration, the new acceleration that it had, a2, moving up. Remember, it's now in free fall, so it's moving, it's opposing the acceleration due to gravity. That's why we have a negative. Because remember, acceleration is also a vector. That means it is magnitude and direction. And since A in this case, which is G, the A2 is equal to negative G, right? Because it's opposing G. Remember, G is always acting vertically downwards. That's why the acceleration due to gravity is always acting vertically downwards. That's why things fall. If you throw anything up, it always comes back down, right? Because gravity is pulling that object down. So acceleration due to gravity is always acting down. So when we denote it as acting up, that means it has to have a negative. So that's our negative right there. So the v2 squared is v2 squared, which is this one, is going to be equal to 0. The u2 squared, which is the initial velocity that it had after the 1.3 kg had reached the floor, right? It's the 2 root 3, right? So we're going to square that plus 2, the a2, which is now g, negative g, right? So it's negative 10 multiplied by s2 or s max, right? Then I take that to the other side. S max is going to be equal to 2 root 3 squared divided by negative, this is the negative 2 multiplied by 10, right? Like that. Then I'll get my S max is 0.6 meters, right? So what is this 0.6 showing me? It's showing me that after particle A has reached the plane, particle B travels a further 0.6 meters, like that. It travels for the 0.6 meters. for the 0.6 meters there. That is S max. Before it comes to rest, then it starts to fall now. 0.6 meters. Therefore, now the total distance that we have is 2. This 2 here plus this 2 plus 0.6 meters, which gives us the total maximum height from the plane as the total max height. Total max height is equal to 2 meters plus 2 meters plus 0.6, which will give me a total max height of 4.6 meters. Right. Remember what the question was asking? Let's go back to the question. It said here, find the greatest height of the particle of mass 0.7 kg above the plane. We just found that from above the plane. Right. It goes all the way up to 4.6 meters. And that's our answer for 6 part 2. Okay. Alright, if you want, you can take a screenshot. I'm going to clear that space for question 7. Okay, so that's it for the first part. The acceleration is given in the function, and then when acceleration is negative, it's decelerating. That means acceleration is negative. That is less than 0. Substitute that equation for a. Substitute for a. A is 60 minus 2. Then we simplify. T is less than 2 over 6. Simplify. T is less than 1 over 3. Since you know that T is always an element of the positive reals, right? And the particle starts at a point O. We write the set of values from 0 to T is 1 over 3. From that range, the acceleration will be negative. You can prove it by plugging in any number that is between these two, with the exception to the limits, into this equation, and you see that the acceleration will always be negative. All right. So the second part, I will clear the space for the second part. Okay, so for the second part, we're going to use calculus. Okay, so this is what we know. We know that acceleration A is equal to dv dt, the rate of change of the velocity with respect to time. We also know that the velocity is equal to ds dt, right? Thus, if we differentiate this twice, we'll get the acceleration, right? Because if we substitute that v there, we're going to get acceleration is the second derivative of the displacement with respect to time, right? Like that. 2s, we're going to get d2s with respect to time twice, like that. So if we integrate this twice, if we integrate that once, we'll get that. We integrate we integrate that once, we'll get that. Then we integrate again, we'll get that. Right? This function, right? Then we'll get our s. So I'm gonna write it like that. We've got 2. We have to integrate twice. Okay. All right. So I'll start off with the a is dv dt is equal to 60 minus 2. Then I'll solve this simple DE, separation of variables. This becomes dv is equal to 60 minus 2 dt. Integrate both sides. I'll get v is equal to 3 t squared a to the power, then divide. Same here. It's 2t. Get the power of t to the power of 1, then divide by 1, you just get 2 then plus the constant of integration. Do not forget that. Okay, right. Then I have to do it again. Remember, v is equal to ds. So we know that v is equal to ds dt. So that's now equal to 3t squared plus this plus 2t plus c. Then I do again another separation of variables. ds is equal to 3t squared plus 2t plus c dt. Integrate both sides again, right? Then this will become s is equal to, when I do that integration again, add the power. So here, add the power, you get 3 divided by 3. Now you get t to the t cubed. The same here, add the power, divide, and you get t squared plus the c now can be ct. Okay, ct plus a new constant of integration. I'm just going to call this one c2. Okay, new constant of integration, right? Then we use the initial values that we got. The question told us these initial values. We have when t is 1, s is 7. Then we also have when t is 3, s is 29, right? So these are the values that we use. These are the values that we use, right? Okay. To make two equations. And then solve for the values of c1 and c2. Okay. So in this case, you could have just labeled them c1 as b, as a, and c2 as b, whatever you want. Okay. So I'll plug in this one first. When I do so, I'll get 7 is equal to this is 1 1, so that'll give me 0. Then this will be 1 plus just that. So I'll just get c1 plus c2. Then that's my first equation, right? Then I'll plug this one second. When I do so, I'll get 29 is equal to 3 minus 3 squared plus c1 3 plus c2, right? And then I'll simplify. I'll get 3c1 plus c2, all of it is equal to 11. Then that's equation 2, right? Then I can solve these two equations simultaneously. Okay, so I have this equation, and I also have this equation like that. Okay, then I'll solve those two simultaneously. Rearrange them to just gonna rearrange this top one here to c1 plus c2 is equal to 11, right? Then you can subtract to get rid of this, the c2s. When I do so, I'm gonna get 2c1 is equal to 4. Therefore, c1 is equal to 2. Then I'll plug in the c1 in any of these equations. I'll plug it into 1. Therefore, c2 is equal to 7 minus 2, which will give me 5. Right, there you go. Now you have you plug it back into this main equation here to get your function of s, which is the function of s with respect to time, right? So s is equal to t to the 3 minus t squared, so it's t cubed minus t squared plus 2c plus 2t, right? c1, substitute for c1, plus 5 for C2. All right, then that's our equation, right? B, final equation. That's it. We found S in terms of T, right? And then the final part for this exam, find the time when the velocity of the particle is 10 meters per second squared. All right, so I'm gonna use the velocity. Remember, we found V here. We found V is that this was C1. Remember, this was C1. So I'm just going to translate that B. It's going to translate that D. It will become V is equal to 3t squared minus 2t plus t plus 2. C1 was 2 when V is equal to 10. So I equate that to 10. 3t squared minus 2t plus 2 is equal to 10. Then I can take the 10 to the other side. 3t squared minus 2t plus, it's now negative 8, right? 2 minus 10 is negative 8 is equal to 0. Right, this is t squared, like that. Okay, then you could factorize. Multiply 3 by negative 8, you get negative 24 t squared. Then you've got to find two numbers that will multiply to give you negative 24 t squared and 8 to give you negative 2. And those two numbers would be negative 60 plus 40. Then you can replace the negative 2 by those two numbers so that you can factorize. Minus 60 plus 40 is 8 is equals to 0. And you can factorize. This will become 3. Take out the 3t for this part only. Get 3t, t minus 2. You do the same here. You take out the 4. Factor out the 4. T minus 2 equal to 0. Therefore now you have 3t. Or you could have just used the quadratic formula. It works as well. Plus 4. Then that's a common. You can now factor out the 2 minus the t minus 2 bracket. Then this is what you have. You can equate that to 0 to get your two values of t. 3t plus 4 is equal to 0. t minus 2 is equal to 0. T is equal to negative 4 over 3. But we know that that cannot be possible because t is an element of the positive reals only. Right? We know that. So whenever t is negative, we're going to discard this solution. Throw it away. Is equal to 0. Thus t is equal to 2. See, that's it. So that is the value. It says find the time when the velocity of the particle is 10 seconds. Right? If you plug in 2 into this equation, yeah, you get your velocity as 10. That's how you can check. All right. Thank you guys for watching. Please don't forget to subscribe, and I'm going to continue doing these papers. To allow me to continue doing these papers, please just subscribe to motivate me to doing these papers for you. Thank you very much for watching.